by 4 systems of equations, so 10 by 10. So we won't teach it too much anymore because graphic calculator will do it for you. So I'm going to show it to you. Graphic calculator, you can use that on the SAT 2 test. Okay, so let's start with number 1. So if you have a matrix like this, which is a 2x plus 9 and then negative 9, these are the columns. First column. Second column is negative 7 over 4n plus 7. And they say that's equal to the matrix 6, negative 9, negative 7 over 8m minus 9. And then you have to solve for each variable. Basically what that means is if these two matrices are equal to each other, and these are 2 by 2 matrices, then that portion has to equal to that part. So whatever's in the first row, first column has to equal each other. And then what is in the second row, and these are the rows, and these are the columns. Okay, second row, second column has to equal to what's in the second row, second column there. So we're going to set 2x plus 9 is equal to 6. We're going to solve for x, so 2x is equal to negative 3, and x is equal to negative 3 over 2. That's done. And then we're going to set 4m plus 7 is equal to 8m minus 9, and then take that to the right, take that to the left. That's 16 is equal to 4m, and so my m is equal to 4, and that's done. Okay, that's how you solve something like that. Alright, now let's get to number 4. Alright, in number 4, they give you a matrix which is 2 by 7, okay, negative 3, 0, 2, 4, negative 6, negative 8, and they want you to find the term a to 3, okay, in this matrix. So this is the row and this is the column. Okay, so we're going to the second row, which is that, okay, and then third column, which is that. So a sub 23 is negative 6. Okay, so let's get to adding matrices, which is number 6. So they give you a matrix A, which is negative 9, 7, negative 8, 1, 5, negative 3, and then they want you to add matrix negative 5, 9, negative 3, 1, 5, 3. Okay, that means you're going to add what's in the first row, first column to first row, first column. So that is going to give us negative 14. Then first row, second column to first row, second column. That is going to give you negative 11. And then 5 plus 5, which will give us 10. And then 7 plus 9, which is going to give us 16. 1 plus 1, which is 2. Negative 3 plus 3, which is 0. And that is your matrix, new matrix when you add that. Same thing works in subtraction. So if you were to, instead of addition here, if you were to subtract, then you're going to go have negative 9 minus a negative 5, which means it's really negative 9 plus a 5, and the answer would be negative 4. Or another way of doing it is when you have a minus in the middle, you can just distribute the negative sign throughout each one of these, and then just add the terms. That's probably a little easier. Alright, now I don't think I should have to do number 8. 3 by 3 works the same way. So let's go ahead and do the subtraction. So let's do number 10. Okay, 33 and 40 is the first column, negative 38 and negative 28 is the second column, and then minus negative 29, 16, and negative 10 over and 9. Right, if you were to, you can rewrite this if you want. Write this as 33 over 40, negative 38 over negative 28, and then change the plus into a minus and distribute the negative sign, which is going to give us 29, 10, negative 16, minus 9. Now we just add them together. Okay, 33 and 29, that is going to give us 4262. Okay, negative 38 and 10 is going to give us negative 28. Okay, 40 minus 16, that is going to give you 24. Negative 28, negative 9 is going to give you negative 37. And that's it. Okay. Alright. Now, let's look at number 13. Number 13 is that x minus 3 minus 4 2, 7 has to equal to matrix negative 8, 0, 4, and negative 3. Okay, so they want you to find out what that matrix is, the x matrix. So it's simply, you're just going to take that to the other side. So my x matrix is going to be the same thing as negative 8, 0, 4, negative 3, and then plus the matrix 3, negative 4, 2, 7. Just take it to the other side, the equal sign. Now when I add these two things together, my matrix X will turn out to be negative 5, negative 4, 6, and 4, and there it is. Okay, so that brings us to multiplication, which is a little bit more complicated. Okay, number 19. Number 19, you have a negative 4, 5, 3, 8, and then you have 3, 3, negative 8, 4, and they want you to multiply. So when you multiply these, what you're going to do is you're going to take the first row, multiply by the first column, and then you're going to put that answer in the first row, first column. So first row and first column, that's where the answer is going to go, because this is row 1 and this is column 1. So we're going to put the answer in row 1 and column 1. So when you multiply, you're going to multiply negative 4 times 3, which is negative 12, plus 3 times 3, which is 9. And then you're going to take row 1, multiply by column 2. And then, of course, the answer is going to go in row 1 and column 2. So negative 4 times negative 8 is 32. And then 4 times 3 is 12. And then we're going to take row 2 and then multiply by column 1. Okay, so when I multiply by column 1, okay, we're going to multiply 5 times 3, which is 15, and plus 8 times 3, which is 24. And then finally, row 2 times column 2 is 5 times negative 8, which is negative 40, and then plus 8 times 4, which is 32. And we just simplify, and the answer turns out to be negative 3, and this is going to be 39. And then over here is going to be 44, and then this is negative 40 plus 32, which is negative 6. And that's how you multiply. Alright, so we also have what's called a scalar multiples, and that is, let's say, number 22. Okay, they tell you A is equal to 8, 4, 3, 5. So they want you to find 3a, means multiply this by 3. So 8, 4, 3, 5. And that is going to give us 24 and 12, 9, and 15. Alright, so moving right along. Okay. Let's see if we have any. Oh, yes we do. We have an inverse matrix. Alright. The other thing is, okay, let's do an example of a matrix where you can't multiply. So let's say I have 1, 2, 3, okay, 4, 5, 6, and I want to multiply by another matrix 2, 3, okay, and 5, 4. Right. This does not work, and I'll tell you why. When you go to multiply row 1 times column 1, okay, the 1 is going to be multiplied by 2, the 2 is going to be multiplied by 3, and there's nothing to multiply the last number, 3. So that means the number of columns, and this one has 3 columns, okay? But it has to match up with the number of rows. That's a question that shows up on SAT too. So this one has 2 rows, okay? So whatever the number of columns you have in the first one, you have to have the same number of rows in this one, okay? So let's go the other way. Let's say you have 2, 3, 5, 4, okay? And then let's say you have 1, 2, 3, 4, 5, 6. Okay, now can you multiply these two? Okay, so when you go to multiply, first row times that. So 2 is going to be multiplied by 1, and 5 is going to be multiplied by 4. That's good to go. Okay, and then 2 and 5 is going to be multiplied by the next column, and that will match up. Okay, so this one has 2 columns, and this one has 2 rows. Okay, so the number of columns in the first matrix has to match up with the number of rows. And let's say I have a x plus y is equal to 4. Okay, we want to solve this 2 by 2 equation, system of equations. And that's easy because we can do the elimination method. So when we add, we're going to get 3x is equal to 14. So you know what? Let's make it easy on ourselves. Let's make this into a 2. Okay. So 3x is equal to 12, and x is equal to 4. And then how do you solve for y? Just plug it back in either one of the equations. So you're going to get 2 times 4 minus y is equal to 10. That's 8 minus y is equal to 10. And then y is going to equal to negative 2. Okay. So we know what the answers are. Okay. What happens if you have 10 by 10 or 20 by 20, which you'll have to do in linear algebra? So you'll need to know how to do the matrices. Okay. So if I want to solve this, there's the method. There's a long way to find. Inverse is kind of like messy to find, but in calculator you can find the inverse of this. So all we're going to do is we're going to have the matrix, okay, of the coefficients, which is 2, 1, negative 1, 1. And then we're going to take the inverse of that matrix, and we're going to multiply that by the constant matrix 10 over 2. Okay. Of course, this part right here, finding inverse, is really ugly messy with determinants and everything, but we have a graphic calculator, so let me show you how to do that. Okay, so what we're going to do is to get the matrix, there's a brackets, okay, that's underneath the T, okay, and I'm going to start with the bracket, and I'm going to type in my first column right there, and to do that, it's going to be 2, comma, negative 1. Okay, and then the next column I'm going to type in is 1, 1, but I have to use, when I change rows, the next row I'm going to type in, when I change rows I have to use semicolon, which is above 9. So the second row is going to be 1, comma, 1. Okay, and then I'm going to close my matrix, which is bracket, which is above the division sign. Then I'm going to take inverse of this. That means I'm going to raise this to the power of negative 1. And that's what this is right there. And I'm going to multiply that by, okay, second matrix, which is bracket, and then I'm going to go 10. But the next row, that means I have to use a semicolon, which is above 9, and 2, and then close my brackets. Okay, and I hit enter. And I should get 4, negative 2. And there it is. Okay, and this turns out to be 4, negative 2. Okay, and that is my x, and that's my y. And there it is. And you can do this by 10 by 10, 20 by 20. You know, it doesn't matter. You can make up an ugly matrix. Let's make one like, say, 4, 5, 6, 7, 1, 2, 3, 4, 9, 10, 6, 1. Okay, and let's say we have 4 equations, so we need 4 unknowns, so we need one more column. So let's say 10, negative 2, 4, 3. Okay, And so we have 4 equations, and we have 4 unknowns, and then we're going to take inverse of that, and let's say my constants, the column was 1, 2, 3, 4. And I want to I'm going to multiply this, and when I multiply these two matrices, I'm going to get what is my x is equal to, my y is equal to, what's my z is equal to, and let's say my last variable is what w. And that is going to give it to me in terms of a matrix. It's going to line up just like that. Okay, so I'm going to get a number here, 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 here. So it's just too long to punch it out, but you can punch it out and you can solve a 4 by 4. All right. So let's do something a little not as long. So let's say let's make one that is easy. Let's say 3 by 3. Okay. So let's say I have a 3x plus 2y plus z is equal to 2, and let's say I have a minus 4x plus 10y minus 3z is equal to 5, and let's say I have a 4x plus 3y minus 2z is equal to 1. Alright, so what is my matrix? My matrix here, if I want to solve for x, y, and z, I am going to have a matrix of a 3, negative 4, 4, 2, 10, 3, okay, 1, negative 3, negative 2, okay, and the inverse of that. Okay, so let's go ahead and find the inverse. Let's do one step at a time, but you can punch this in all together like I did the last problem. I want to show you what the inverse is. So I'm going to type in the first row, which is 3, comma 2, comma 1, and then the next row I put a semicolon, so it'll be negative 4, comma 10, comma negative 3, and then I get another semicolon. Okay, and then my last row is 4, comma 3, comma negative 2, and then I close my brackets, and then I'm going to raise that to the power of negative 1, and this is the inverse matrix. So sometimes they'll ask you what's the inverse matrix. There it is. That's how you find the inverse matrix. Let's say we want to multiply that inverse matrix, okay, by this 2, 5, and 1. If we do that, we should get the answer for my x, y, and z is. Okay, so let's go ahead and punch those in. So brackets, okay, 2, and semicolon, and then 5, and semicolon, and 1, close the bracket, hit enter, and there it is. So my x is equal to, so this tells me 0.2024, 0.68, and 0.568. So that means in this 3 by 3, my x is equal to 0.024, and my y is equal to 0.68, and my z is equal to 0.568. And you don't need to use elimination method, substitution method, any of that nonsense. Okay, you can just let your graphing calculator solve by systems of equations. Okay, all right. Now I do want to show you how you can add and subtract matrices too. So I'll multiply. Okay, we just did multiplication, so we'll do that for you. So let's make up a simple one: 2, 3, 4, 5, and I want to add. Okay, 1, 2, 4, 6. Okay, so let's punch it in. Okay, so we're going to go 2, comma 4, and semicolon. Okay, 3, comma 5. Okay, close the brackets. Okay, and then I'm going to add. Okay, open bracket, and that is 1, comma 2, and then semicolon, and then 1, comma, 1, comma 4, 1, comma 4. Okay, and then semicolon. Okay, 2, comma 6. Close the brackets. Let's see, I punched everything in correctly. 2, 4, 3, 5, 1, 4, 2, 6. Yep, hit enter, There it is. It'll add it for you. If you want to subtract, very simple. Just go over here, okay, and delete that. Minus, hit enter, subtract the 2. If you want to multiply, same thing. Here, change that to a multiplication. It'll multiply 2 matrices. And there it is.